In this video, I want to look at inverse functions. So before we look at inverse functions, let's start with the idea of what is a function, or let's recall what a function does. So a function takes elements in the domain, oftentimes we consider the x elements, sends them to elements in the range. That's what a function does. The inverse function, which we denote f to the negative 1 of x, inverse function, undoes this. It takes all the elements in the range and sends them back to elements in the domain. It undoes what the function had done. So if we take a non-equation example, if we take a bubble flowchart here, let's say we have letters A, B, C, and all these letters are capitalized. I'm going to create a function that takes all these letters and sends them to their lowercase letter, A, B, C, so forth. We see that A has a direct pairing with A, B, B, C, so forth. What an inverse function would do, it would come take all these elements in the first bubble of the domain and send them right back to, the function sends all the elements in the domain to the range over here on the right hand side. The inverse function is going to send all of those lowercase letters back to their uppercase letters. It's undoing what we had done before. Now this is possible because this is a one-to-one function. What one-to-one function is this function where we have those unique correspondence between domain and range. There's only one pairing for the A's, one pairing for the B's, so forth. There's no second place that B can go. A function must be one-to-one in order to have an inverse. Each element of the domain must correspond to a unique element in the range to have an inverse. So let's look at something that's not one-to-one. Let's say we have a bubble here where I have words, apple, boy, ball. Any word can go inside this domain function, domain of the function, and my function is going to just pull off the first letter. So we have A, B, we'd have another B. So what we see is we have two words going to the same element in the range. We have repeated elements in the range. So this is a function because each element in the domain goes to only one place, but it's not unique. So if we want to try and come back the other way, if I start with B, I have a problem here. I don't know if it's supposed to be going to boy, ball, bear. There's a lot of different possibilities there. So for that reason, there is no inverse. This is not one-to-one. So let's take an example of something that has an equation. Let's look at y is equal to x minus 3. So first question might be, is this one-to-one? So if we look at this thing visually, sometimes that helps. This is a line, has a slope of 1, a y-intercept of 3. So what we see is every single x has a unique y. There's no repeating y's. And so what I've done is I've drawn a bunch of green lines to indicate that this is one-to-one because it passes the horizontal line test. Much in the same way we had the vertical line test to test if a function was a function, we can use the horizontal line test to test if it is one-to-one. And in this case it is, because each horizontal line only touches a function once. So let's just say I stuck in a value for x. Let's say x is equal to 4. Well, then y would be equal to 4 minus 3, which is 1. That's what the function did. If I want to have an inverse function, or if I want to be able to undo that, I need to be able to plug 1 in for my x and get back to 4 being the y. So I'm going to go and write out what the inverse function is so we can see what I'm talking about. The inverse function is going to be x plus 3. It undoes what we did before. So if we start with that y this time, I'm going to plug in 1 for my x. Notice what we get back to 4. So the function took x of 4 to y is equal to 1. My inverse, that's really what we're looking at in the second equation at the bottom, the inverse took that 1 back to 4. It undid what we had done before. Let's see how we can formally find these. Let's take another function, 3x plus 2. Once again, this thing is linear, so it is going to pass the horizontal line test. For every x, we can see that there's only going to be one unique y. We're not going to get repeated y's out of this. And first thing I'm going to do, I'm going to rewrite this f of x as a y, just so it's going to be a little easier to manipulate. And what an inverse is doing, what we're doing with these inverses, we want to send the x's back to y. So I'm going to literally switch the position of the x's and y's and solve for this new y. I'm undoing what I had done before. I'm switching the positions of the x's and y's. So now I'm going to solve for y. So I'm going to subtract my 2 over and then divide by 3. So y is going to be equal to x minus 2 over 3. And that's what my inverse function is. My inverse function, x minus 2 over 3. F of x is equal to, don't need my parenthesis there, x minus 2 over 3. There's my inverse function. If we do a little bit more complicated example, let's take function to be equal to 2x minus 1 over 2 minus x. So start off the same way. I'll replace f of x with y, 2x minus 1, 2 minus x. I'm going to switch my x's and y's, so y has become an x, my x's become a y, because that's what an inverse does. It switches the x's and y's, or it's sending the y's back to x's. I'm going to solve for y, so I'm going to multiply this denominator, this 2 minus y, to the other side. So we'll have x 2 minus y equals 2y minus 1. I need to solve for y, so I need to distribute this x on the left-hand side first, so 2x minus xy equals 2y minus 1. I'll move my y terms together, so I'm going to add this xy to the right-hand side. And I'm going to also move everything that's not a y to the other side. So at this point, 2x plus 1 is equal to 2y plus, that's plus xy. Now that I have my xy terms on one side, I can factor out the y. So at this point we have 2x plus 1 equals y times 2 plus x. I'm going to divide off the 2 plus x, so that's going to leave me my y, or my f of x, going to be equal to 2x plus 1 over 2 plus x. So notice there are some similarities with where we started. The fact that purely the signs changed, that was just coincidence. Another thing to notice how the f of x, we call it f to the negative 1 of x. That is just the function notation for an inverse function. That is not saying 1 over f of x. If we have something like 2 to the negative 1, that is equal to 1 over 2. Same is not true of function notation. This is very much false. That's not how inverses behave. We have to find inverses using these methods that we've been looking at. Very quickly, let's take an example of a graph too. So let's say I come up with a non-regular graph. So this graph is going to start at negative 2. It's going to go to negative 1 on the x-axis, and then it's going to go up to 2 at the y-axis. So just a very small graph here. And I want to find the inverse. Well, we've been doing this algebraically using the equations, but what if we want to do it graphically? All we're doing is we're switching points. So if we take this first point right here, this is point negative 2, negative 1, and the inverse, that's going to have to go to negative 1, negative 2. Negative 1, negative 2 right here. Next point we had was negative 1, 0. It's going to have to go to 0, negative 1, because what an inverse does, it switches the x's and y's. Our next point was 0, 2, and become 2, 0. And so we notice that my scaling is a little different, that's why it looks shorter, but we get the same looking shape, but it's kind of been twisted a little bit. And so one way we can think about these is it's a reflection over the line y is equal to x. So we have a line y is equal to x, this red dotted line here. And if I were to fold my paper over on that dotted line, I would get back to the other function. But the easiest way to find it is just by taking those x and y positions and switching them. Now what this means, as far as the domain and range, the domain of the function has to be equal to the range of the inverse, and the range of the function has to be equal to the domain of the inverse. Because we're switching those x's and y's, well, the domain is just all the x's of the function, has to become the y's of the inverse, and the range of the function, the y's of the function, have to become the x's of the inverse. The most important thing to remember about these inverse functions, an inverse is just undoing what we had started with. So we are purely switching the x's and y's. If we can remember an inverse function switches x's and y's, that can solve our problem regardless of if it's an equation, a graph, could just be a series of points or a series of numbers. Inverse switches your domain and the range.